Okay, so today we're talking about partial fractions. Woohoo! They're very exciting, and I am not going to wrap the lesson, although that has been suggested to me. And since we have a lot of people gone today, I decided to do the little headphone thing, and this will be on my YOLO site as well. Um, I just like partial fractions. I don't know why. Recognizing partial fraction decompositions of rational expressions, which sounds like, worse than it is, and find partial fraction decompositions of rational expressions. That is what we're doing today, and I have a little kind of introduction to that. So here is the picture that talks about that. So here we're going to take something like a big fraction like this, x plus 7 over x squared minus x plus 6, and we're going to turn it into, oh, wait, quick, what do I pick? Don't show this message again. Well, one time somebody told me to pick that, so I just decided to go with it. So then we're going to get this into two separate fractions. So in your previous math life, you've gone from this right set to this left set. Do you agree with that? That you've had two fractions, you've had to get a common denominator, which you needed a factor of x minus 3 and x plus 2. You multiply this first fraction by x plus 2, you multiply this over x plus 2, and then the second fraction by x minus 3 over x minus 3, and then you ended up with this. So now today we're just going the opposite way. We're starting with the big fraction, and we're going to make it into like the little parts of fractions. So the trick is kind of figuring out how to do that, and it is a little more unique than going the way that you've done that before. So the uh, partial fractions were on the right there, and that is the partial fraction decomposition of the left side. Oops, I missed kind of the big thing. So things to keep in mind are if it's an improper fraction, you have to divide it first and kind of get that remainder that you write as a fraction. So that's when it's an improper fraction, and that means the degree of the fraction on top is higher than the degree on the fraction on the bottom, or they could be equal and you could still have to divide. So when the degree of the top fraction is greater than or equal to the degree of the bottom fraction. So you have to do that little first step of dividing, and then you get this fraction of n sub 1 x over d of x. Dx. And now once it's this way, then you're going to go through this system of things. To me, when you read this, it's kind of a lot to take in, but in practice, I think if we just do a couple, it'll kind of work its way out. The big things to remember is that the next step then is to factor the denominator, which you could have kind of guessed from that last one. And then you're going to set up linear factors. If you have linear factors, you're going to have, and if you have a linear factor that's like x plus 3 to the third, then as your partial fractions, you have to have something over x plus 3, something over x plus 3 squared, and something over x plus 3 to the third. And you'll see that kind of as we go through. And then if there's a quadratic factor, then the partial fraction part on the top is like bx plus c. And if that's raised to multiple or a higher power than 1, then you have to have multiple fractions that match that. Now, when you're looking at this, kind of the way it's written here, I'm just going to tell you in practice something that I'm going to do and the book authors do and everybody does. See how they're calling it, and I am going to write as I do this, but I'm going to erase this. See how they call it A sub 1, A sub 2, and then A sub M? Well, really, we're going to call it, we're just going to use in practice like A on the top of that one, B, C, D, and so on. And then, you know, if I have, you know, bx plus c, then in the next one I would have a, b, c, d, x plus e, and just kind of keep going through the alphabet rather than doing all this subscripting. Does that make sense? Give me a little head nod if you're with me on that. That instead of all the subscripting, I'm just going to use a bunch of letters, A, B, C, D, E, F. And hopefully I know my alphabet, but it's a little shaky sometimes. Okay, so let's do one of these partial fraction decompositions, the following. So here's our problem. Number 1, it's x plus 7 over x squared minus x minus 6. And the first thing I'm going to do is factor the denominator. So I just wrote the problem. Factor denominator. And so that factors into two sets of parentheses, x and x. What multiplies to be -6 and adds to be -1? 3 and 2. And which one is negative? 3 and plus 2. So once I've factored that denominator, then I'm going to write that this is equal to, since there, and I am going to make this statement, a couple statements right now. So this was not an improper fraction because it's a plain x over a plain x squared as my original thing, plain x to the 1 and x squared there. So I don't have an improper fraction. I didn't comment on that before. And then my denominator, when I factor that, notice they're just raised to the first power and the first power. There's not a repeated one. So I don't have to have, you know, extra things, and I'll go through that in probably the next one or two. So I'm just going to say this is a over x minus 3 plus b over x plus 2. So I'm separating it out like this. And I'm maybe just gonna take a picture of this and slide it down a little bit. Ooh. And so now that I took a picture of this, I'm going to go to the next step. So I don't know, just for the people who are watching this, or if you just look at the actual SmartNote file, it's a little easier to follow. So in this problem, we're going to, we now have a fraction equal to a fraction plus a fraction. I just want to clarified that it is not our job to solve for x or anything like that. Do you know what I mean? We're not doing that. We just want to figure out what can be a, what can be b that, you know, would give me this original fraction. So our next step is just to clear the fractions by multiplying by the common denominator. And if we've done everything correctly, that is the common denominator, correct? This thing. So what I'm going to do, my common denominator is that factored denominator. I'm going to multiply, and I'll write them in as fractions. X minus 3 times x plus 2 times that factor, x minus 3 times x plus 2 times that factor, or that fraction, and x minus 3 times x plus 2 times that fraction. And since these are linear factors, I could just use a and b. If they're quadratic, I have to do more. So now I'm going to cancel. I know those are identical from my above factoring. I'm going to cancel my x minus 3's there and my x plus 2's there. And then I get a very nice little equation. I get x plus 7 on the left is equal to, and since we have a lot of people gone, I'll write that without multiplying it. A times, in parentheses, x plus 2 plus b times, in parentheses, x minus 3. And now I just go through and clean that up just a little more. So x plus 7 equals ax plus 2a plus bx minus 3b. And I can clean that up yet again if I want to, or I can just leave it like that. Now, the next part is kind of a choice, and so that's something to kind of think about. I want to figure out what A and B are, and I've got that X in there and everything, and so I can just pick convenient values of X to put in there, because X can be anything as long as all the X's are the same thing. I'm good to go. So I'm going to write that with this green marker. I can pick a convenient, I think that's spelled right, values, or A. I shouldn't have A there. Pick convenient values for X. And I'm probably going to pick them so that, so the factors x plus 2 and x minus 3 are equal to 0. And if you're not sure why that's a good idea, you know, kind of as you look at this, and maybe I could have left it like that, that might help you figure out why I'm doing that. So that's my note to myself. So having said that, I'll let x equal, well, what would make this 0? Negative 2. So let x equal negative 2. And actually, I'm going to cross this out because I kind of just got in that little realm because I always distribute things. And I'm going to look at the one I have boxed. So if x is negative 2, that gives me this. Negative 2 plus 7 equals a times negative 2 plus 2 plus b times negative 2 minus 3. So do we agree that a canceled out, right? Why is that convenient to us? Because now I'll be able to figure out what b is, and I have no x anymore because I picked a value for x. So 7 minus 2 is 5 equals negative 5 times b. When I divide by negative 5, b is negative 1. And then my other convenient value of x, when I look at kind of this part, what's that going to be? Let x equal 3, and I'll go back up to my top one. 3 plus 7 equals a times 3 plus 2 plus b times 3 minus 3. What happens to the b one? It cancels out. And 3 plus 7 is 10 equals 3 plus 2 is 5, 5a, and that canceled out. So a is what? 2. And then I can write my decomposition of my original problem. I don't know, I can't make this slide longer. I'm not sure why I'm not there. And so then my answer, since I can't see my top problem, I'll just copy it from here. 7, or x plus 7 over x squared minus x minus 6 is equal to, now I have my partial fractions up there, and I know it's a over x minus 3, so 2 over x minus 3. Now, b is negative 1, so I can write a plus negative 1 there, or I can write minus and a 1 over the fraction. Do you agree with that? And so the book authors have done both. Usually if there's something they can distribute out, they'll kind of do it that way. So for this one, though, I'll just write plus negative 1 over x plus 2 was what we had there. So I've separated that into two partial fractions related to my original problem. That's example 1. I think we'll go right to example 2, and I'll maybe come back and look at another one of those maybe to Monday at the beginning of class or something. So this is just kind of going through that one, and now this next one I picked here is a little, oh, there we go. I'll make it a little bigger so it's easier to see. The reason this one is one that we're going to do is this is an improper fraction. So this is an improper fraction because it's x to the 4th here over x to the 3rd there. So this is higher than this power. So this is an improper fraction, and I have to divide it, just old-fashioned long division, and kind of see what happens. So I'll write myself a note. This is an improper fraction. So divide first. And the thing we have to do then is when we divide it, we're going to get that whole part, and it's at the very end not to forget about the whole part, just to kind of make sure that you're aware of that. So I'm going to do this one as a long division. So x to the 3rd plus 2x squared plus x. I'll put in a plus 0, and I'm dividing that into x to the 4th plus 2x to the 3rd plus 6x squared plus 20x plus 6. And when I divide that, x to the 3rd goes into x to the 4th, x times. So I'll just put the x right there. And then I'll distribute that. That's x to the 4th. This is a good, actually, this is a perfect review as we get kind of closer to the final exam and all that kind of stuff of just reminding ourselves how to do this. Plus 2x to the 3rd plus x squared plus 0x, and then I'll remind myself I like to just write in all my changes of sign there. X to the 4th cancel out. Gee, so do the x to the 3rds, and then 6x squared minus x squared is 5x squared plus 20x, and then plus 6. And will this x to the 3rd divide into 5x squared anymore? No. So that is going to be, this is now going to be x. My answer, my quotient is x plus this whole thing over that whole thing. So 5x squared plus 20x plus 6 over x to the 3rd, little cramped for me to write, plus 2x squared plus x. I won't write the 0. So this is now actually still just finding the original problem. And that plain x is just going to stay plain x. And this fraction is what we're going to use to do that process that we did before. And in this one, I think we're going to find just a little uniqueness there. So this is an excellent problem because it requires us to do a bunch of things. So now just look, oops, just look at the fraction. To get those partial fractions, and I have to remember the x for the very end. Okay, so you guys are going to help me remember the x for the very end. So my first thing is, and I'll just rewrite it here, 5x squared plus 20x plus 6 over x to the 3rd plus 2x squared plus x. My first thing is to factor the denominator. What do you notice about that? That I can take out a factor of x, so that's x times x squared plus 2x plus 1. What does x squared, well, let me just try to factor this. What does that factor into? X plus 1 and x plus 1. So truly, this is x times x plus 1 squared. Do we agree with that? So the wonderful thing about this one is now I have this multiple powers of one of my factors in the denominator. And so when I have multiple powers, I have to have a fraction that has x plus 1 as the denominator and another fraction that has x plus 1 in parentheses squared as a denominator. So that means that this denominator is going to help me make this just for this piece. So one of my factors is x, so I'm going to have a over x, and x is considered linear because it's x to the first, and then plus b over a single power of that factor, x plus 1, plus c. I'm just going to rewrite my c. C over x plus 1 in parentheses squared. So that's kind of that next step, using all my factors, and if there's multiple powers of something, then I have to kind of keep going. So if it had for some reason been x plus 1 in parentheses to the third, I'd have an x plus 1 squared, and x plus 1 to the third. And these are still considered linear factors because that factor in there is still kind of the linear part. And now I'm just going to rewrite this whole thing. So I am going to take a picture of it if I can find my camera. Maybe I close the camera. So I'm just going to take a picture of this again. This is the piece that I'm going to work with. Boy, I really... Okay, this is what I'm going to work with. You just don't even know how this hurts my ears when I take a picture right now because it's like blaring in my ears, but I'll get over it. Okay, so my common denominator that I'm going to multiply all factors by is this thing to get rid of all fractions. So x times x plus 1 squared. This one, x times x plus 1 squared. Oh, that's the nice thing about doing it that way. X times x plus 1 squared, x times x plus 1 squared. Can you already decide as we're writing this what you're going to let x equal? Hopefully you are. This cancels, I'm going to scratch those out. This and the power there is going to cancel. This and that cancels. So let me kind of just write that down then. So this is 5x squared plus 20x plus 6 equals a parentheses x plus 1 in parentheses squared plus bx times x plus 1 plus cx. I was ready to say more than I had to there. Now we again pick our convenient values for x. Pick convenient values for x. So what is a convenient value of x? -1. So x equals -1. And when I put in -1 there, I get 5 times -1 squared plus 20 times -1 plus 6 equals a times, I said -1, but for some reason I did not write it up there. I'll just rewrite that part. X equals -1. Now, this is a times 0 squared. Do we agree? Because -1 plus 1. And this is b times -1 times 0. And this is c times -1. So, oops, that's a 0. So in this one, that cancels. So I just have to figure out what this little mess on the left is, and that's equal to -c. So -1 squared is 1. 1 times 5 is 5, plus -20 plus 6. And so 11 minus 20 is what? -9 is -c. So c is 9. So I figured out what c is. I did take up a lot of space. What should I let x equal now? What's convenient? Think about my common denominator, or common multiple. Should I let x equal 0 as the next one? So I'll write a line there. Let x equal 0, and then I'm not even going to write all that. What's on the left if x is 0? 6. So 6 equals, now for this one it's a times 0 plus 1 squared. So that one's going to happen. When I put in 0 for b, that'll be 0, or excuse me, x equals 0, b, that'll be 0, and this will be 0. So this is what I get. So what's a equal? 6. A equals 6 for that one. So I've got that. Now how am I going to figure out what b is? Any thoughts on how I can figure out what b is? Or there's no, do you agree that there's no other convenient value for x that would make, things drop out and give zeros or whatever? So there's nothing else convenient. But right now I do know what a and c are. And so I think I can use this big equation, and I'll just circle it a second. I can use this big equation. I can use my a and my c that I now know, and I can pick some other convenient x value, and I'm kind of guessing what might work, and I'm usually, I'm not going to put in like negative 864 for x, you know what I mean, because that's just going to make a mess. I'm going to use little things like 1s or negative 1s or 2s or something like that. So there is no easy other value for x. But we know that a is 6, c is 9, so I'm going to just pick x equal, well, I had negative 1, I had 0, so I'll just pick x equals 1. And then I'm going back into this big long one, and I think I can just clone that and drag it down. And I can tell the smart board is working hard on recording and managing as I go. So now I'll just put in things that I have here. So 5 times 1 squared plus 20 times 1 plus 6 equals a, which is 6 times 1 plus 1 squared, plus b times 1 times 1 plus 1. Plus c, which is 9 times 1. So does that seem pretty convenient? I mean, it's not as great as the first two, but, it doesn't make things explode into huge numbers or anything like that. So this is 5 plus 20 plus 6. This is 6 times 2 squared. Be careful of that. So 2 squared is 4. So 6, I'll multiply that and get 24. 24. This is b times 1 plus 1, so plus 2b, and then plus 9. And then it's just a matter of kind of figuring things out. This is 20, 31 equals 24, and 9 is 33 plus 2b. Subtracting 33, I get negative 2 equals 2b. Dividing, I get b equals negative 1. So now I have b equals negative 1. Now I have to do two things. I have to plug all those in to my partial fractions, right? And I have to remember that I have a whole part that was what? When I did that long division. X. I have to remember that I have that whole part from that long division. So I'm going to go way up here, and I'm just going to say, okay, I'm going to rewrite, and I'll circle what I'm going to do now. I'm going to rewrite, maybe I'm going to circle it in yellow. Let me get rid of that. I'm going to rewrite my problem just so I have that. And then I'm going to write this x plus, and then I'm going to write this and fill in my a, b, and c. And so now that I can see it there and you can see it, now I'm going to go way down here and And I can't see it anymore, but I can write it down. So that gives me an answer of, and I'm just going to copy it right off my paper here because I can't see the top. X to the fourth plus 2x to the third plus 6x squared plus 20x plus 6 all over x to the third plus 2x squared plus x. Equals, and then that whole number x, which was there, plus a, which I can't see anymore, but I found on my paper is 6 over x, plus b, which is, I can see, -1 over x plus 1, and then plus c, which I think was 9 over x plus 1 in parentheses squared. And that is it for that one. Fun, right? Very fun and exciting. I know, I'm sure when I look at my slide, look how it's like a mega long slide, see? So that would be still good on a piece of paper. So I'm going to ask you to, you can work on homework the rest of your time. You might be working on 7.3. I would like to throw out as a suggestion, even though you have 7.3 to work on, maybe you want to try like the first 1 or 2 of these while it's fresh in your mind. Do you know what I mean? And then go back to 7.3. Does that make sense? And so I'm going to give you the rest of your time as work time today while I